Matthew Rosendin is the CEO and co-founder of Trustline Inc. He's going to talk and discuss the issuance of trustless assets like other cryptocurrencies on the XRP ledger and how the cross-currency payment and decentralized exchange features of the XRPL will thrive in the future. Matthew.
Hey everyone, great to be here right now. Just wanted to say that today is National Coffee Day and I had some. Normally I'm a decaf guy and I have a little bit of the jitters, but hopefully we'll be able to get through this okay. So today I'll be presenting about trustless issued currencies. This is sort of a new concept that we're developing at Trustline, and so I'm excited to walk you through it. So really, before we jump into the meat of the presentation, we need to talk about issued currencies. So we're going to go through a quick primer about issued currencies on the XRP ledger. I imagine there are a lot of people here who already know quite a lot about it, maybe some folks on the live stream. This will be helpful for you. So let's jump into it. So the way that we're going to do this is we're going to construct a graph or network topology using some of these symbols. So we're going to just create a language first. So first term to introduce is gateways. So what is a gateway? A gateway is a financial institution that exchanges currency outside the XRP ledger for issued currency in the XRP ledger. So for example, you could deposit $100 with Bitstamp and receive 100 USD Bitstamp as an IOU on the XRP ledger. And we are describing the gateway in our kind of graphical language as this circle with a G. And next thing is issued currencies. So issued currency itself is the IOU that gets issued by the gateway. It represents value held by gateways. And the gateway that issues currency in the XRP ledger is expected to pay the balance back to the holder, right? So it can be any currency issued on the XRP ledger, like Bitcoin. It could be US dollars, gold, rice stones. It could be anything. This is how it's represented. Kind of graphically, you have somebody who holds the issued currency. This is Alice here. She has what's called a trust line with gateway G. She has a balance of 100 US dollars. So we're going to get into the directionality of that arrow right there. It's a little counterintuitive, but this means that gateway G has issued 100 US dollars with Alice. And then over to the right, we have kind of the code, how it's represented in the code. It's a balance. You have a currency code. You have an issuing address. That's who's issuing the currency. You have the value of that balance. And then we have trust lines. So trust lines are a way of configuring how much you trust an issuer to hold on your behalf. You can create a low-limit trust line with your broke roommate, for example, but you may not really expect them to make good on their IOU, right? Or you can create like a higher limit trust line with a reputable financial institution, or kind of like a blockchain program, which is what I'm going to be introducing in a bit. We have our graphical sort of language here. I just added a limit. So limit Alice trusts gateway G with a limit of 1,000 US dollars. So gateway G would not be able to issue more than that. And then the trust line, the directionality, Alice creates the trust line with gateway G, allowing gateway G to issue that currency. That's why the arrow is going to gateway G. Next, we're going to talk about rippling. So this is when more than one trust line is adjusted to make a payment. It occurs when addresses are linked by trust lines that use the same currency code. So that's an important part there. The issuer does not need to be the same. And in our graphical language here, what you're seeing is you're seeing Alice and Bob both have trust lines with gateway G. And if Alice is sending a payment to Bob, the payment can ripple through gateway G because it's just adjusting the two balances on those two trust lines. And it debits from Alice and credits Bob's balance. And that's how rippling kind of happens. You can take that further into multi-step rippling. So Alice sends 10 USD to Charlie. You see Alice to the left, Charlie on the right. You've got gateway G1 and G2. You've got Bob in the center. So Bob could also be like a gateway or just like a regular account. Doesn't really matter. He just needs to have rippling as a setting on his account enabled. And then it can just kind of traverse through that path, reach its destination to Charlie, and credits his account. And G2, right there, who Charlie has a trust line with, is the one who is issuing that currency for Charlie at the end. So now that takes us into kind of like, okay, let's take a step back. What are the thoughts that I have on issued currencies? There's pros and cons. First of all, there's a really high potential for liquidity by rippling through payment paths. Lots of interesting things you can do. Some things that we're doing at Trustline that are really exciting on this kind of same line. They're tradable on the XRP Ledger's decentralized exchange. There's actually quite a lot of things you can do, and there's a growing ecosystem, new use cases, things are happening. Cons, there's an unrealized potential of kind of more complicated paths for payment liquidity, and that's sort of what we're trying to solve with trustless issued currencies, which I'll get into soon. And along that same line, a lack of general fungibility between issued currency assets. Now, there are some things like Trustline quality and whatnot that kind of allow you to see, how much what is the face value of this issued currency, right? But with trustless issued currencies, what I'm going to walk you through is how can we just make sure that all of these trustless issued currencies have sort of the same face value for everyone who is holding it. And then these IOUs also rely on kind of like a trust in the solvency of the issuer. You don't know necessarily if they're going to pay you back. For example, if it's Bitstamp, they have US dollars in their bank account or something. You don't know, you can't peer into their bank account balance and see, okay, can they pay you back? Like, what are they doing with your money? So now we're going to walk through trustless issued currencies since we have sort of that background. So first things first, there's some prior work that has happened, and kind of I stumbled across this blog post by the Flare team, and it's titled Closing the Circle on XRP and Flare Interoperability. It's a proposal on how to issue and redeem assets from Flare on the XRP ledger in a trustless manner. And I'm not going to walk through all of it. I'm going to walk through some of it in a couple of slides, but it's very important to note that this is the prior work. Kind of the other piece of context and angle where this is coming out of is there's this coin Ore, which is a decentralized stablecoin. It's in development. It's kind of like MakerDAO. It's a CDP-based stablecoin. That means collateralized debt position. And it's minted through a decentralized app that will be launching on Songbird and Flare networks called Probity. And it can be represented on the XRP ledger as a trustless issued currency. So this is a blockchain smart contract as the counterparty, or as the issuer, if you will. And so let's just talk about a bit more how that actually works. You've got a trustless issuer. This is just what we're calling it. It works similar to kind of the gateway concept. This is an account that issues currency and then certifies that the trustless issuance has occurred properly, that tokens, an equivalent amount of tokens that are being issued have been locked in a smart contract on Flare network. And so, for example, if you initiate a transfer of 100 ORA from Flare and you receive 100 ORA issued to your XRP Ledger account, that would be transferring from Flare to the XRP Ledger, and then you can redeem these tokens from the XRP Ledger and kind of release whatever tokens are locked on the Flare side. So it's kind of the inverse of that. And then now putting that together, you have the trustless issuer, you've got trustless issued currency, and this is just, again, another term that we put together. There's like some Twitter threads that we were trying to figure out, okay, what's the right term for this? Still not entirely convinced, but maybe this will stick. So this is just a new term for issued currencies that can be redeemed trustlessly from the Flare contract. They're always redeemable for the locked tokens, and just some examples. So like ORA, other F assets can be represented on the XRP Ledger. If Bitcoin becomes an option as an F asset on the Flare network, I can imagine that Bitcoin would make its way onto the XRP Ledger and basically have the advantages of the XRP Ledger if you want to use that to send transactions. And then there are any other sort of ERC20 token, lots of interesting things that can go on here. So now I want to walk you through sort of like the formula for how this all actually works. So lots of text here, I'll walk you through it. So first things first, you want to create a new account. This is going to be the issuing account. And these steps anyone can do. Like, I mean, you might require some expertise on the XRP Ledger and how to do this stuff, but in general, like it's built to be trustless so that you don't need any sort of intermediary. So you create the issuing account, your 5 XRP reserve to create the account. You set the issuing account default Ripple flag. That's just modifying the account settings. You create a trust line from a receiving account. This could be your existing account. If you already have one, create the trust line with the issuing account for X units of trustless issued currency as the limit. So let's just say, for example, like 10,000 units of trustless issued currency. And then you issue precisely that amount, 10,000 units of the currency from the issuing account to the receiving account. And then you have to make sure that there can't be any signer, multi-signature scheme for the account. That's important. We'll get into kind of like how this is guaranteed that there's not going to be multi-signature on the account. And you need to set the regular key of the issuing account to account 1. This is essentially disabling that key, and you also have to disable the master key for the issuing account. And what we call this together is like you don't have any more ability to issue any more currency after doing this. So the term, I guess, is black holing the account so that no more can be issued. Then you send 10,000, in our example, 10,000 units of tokens to the Flare smart contract along with the issuing address that you created and issued the tokens on the XRP Ledger. And then kind of last step is to use the Flare State Connector. This is a technology coming from the Flare side that will be able to read transactions on the XRP Ledger. You will feed it the transaction hash or transaction ID of the issuance. You submit it to this smart contract so it can verify that that transaction happened, that it was between those two accounts for that exact balance. And then kind of to wrap it all together, the smart contract also verifies that the account is set up properly, that it has the key, master key disabled and whatnot. So in the Flare Bridge contract that does this is called Solaris, so more on that soon. This is the formula. It sounds complex, but we're also going to make it much, much easier to do for anyone. So let's talk a bit more about trustless issuers. So these are kind of verifiable, secure, and transparent accounts. There's a universal list of verified issuers managed by the Flare smart contract. So once you do that validation, you verify the trustless issuer, that gets pushed into a data structure maintaining the list of those accounts. And that helps, with kind of verifying, the issuer and that it's not some scammer or counterfeiter. The trustless issuing accounts are black hole. They can't issue any more than they're allowed to. And there's an equivalent amount of funds locked on Flare. It's auditable. It's transparent. Not like, a bank account. So you can verify that. Counterfeiters, they could fit into the equation. They can pose as a trustless issuer, but there's way to thwart that sort of threat. So they won't, first of all, show up on the universal list of verified issuers. It's easy to verify, whether someone's a counterfeiter or not. It's just a call to the blockchain. Is this guy, legit or not? And then you want to make sure, you don't create like a trust line with them or anything. Like they may try to siphon funds. So just beware. That's kind of the worst case thing that I could possibly imagine. So I thought I'd throw that in here. And then they can be avoided just, again, by verifying the issuing addresses in the list when constructing a payment path, which we'll talk about soon. So I have created a sort of structure here to kind of demonstrate what's going on. There's this concept of a liquidity provider that is kind of necessary for this fungibility that I've been talking about and sort of making it easier for the currency to be sent and received and linked together if there are different issuing accounts issuing these currencies. So, in this diagram, we have Alice and Bob. These are the endpoints. You can imagine Alice would be sending, a payment to Bob in a trustless issue currency. And then you have trustless issuers, so that's the TI1 and TI2. And so maybe TI1 has issued some currency to Alice, right? And so Alice can then use that balance in order to send payment to Bob. And the liquidity provider here has trust lines with both issuers, and essentially that is serving as a link between those issuers, and so that they have rippling enabled, and the currency can find its way to Bob, essentially. And why they're called a liquidity provider is because in this example, the liquidity provider would need to have a balance with TI2 in order for rippling to successfully occur, so that the balances can shift along the trust lines there. And so I kind of thought, like, why might someone want to provide that sort of liquidity in the system? And it is possible to earn transfer fees, at least in theory. I haven't worked it out yet, but this is kind of the next stage for that area of research, how you can actually earn by providing this sort of liquidity. All right, so next thing I wanted to touch upon is, like, why do this at all? Why am I interested in it? I think I got interested in kind of the credit card interchange rates, and I looked into it. So there's the stat here in the United States. The average interchange rate is around 0.3% for debit cards and 1.8% for credit cards. I think we can do better than that. I think regulations are kind of keeping that artificially low. And I think blockchain and Web3 is kind of the next frontier in order to improve upon this system. And payments could be processed more cheaply than debit card and credit card transactions. The merchants will like that. They end up paying this fee mostly, and if you've ever used Venmo and used a credit card on Venmo, that is, it actually, you're the one who's charged for that because there's no merchant to pick up that fee. So, you know, the other reason why this is interesting to me is because there's this stat that there's like 10% of Americans that are underbanked or not banked at all, and that's kind of unacceptable, so we have to do better and figure out how we can improve that situation, and I think that we can do that. So again, going back to XRP, what is the role of XRP in this? Of course, Trustline creation and auto-bridging actually would factor into this. It's an area of kind of how we can use auto-bridging, area of research that we need to look into a bit more, and how to use the decentralized exchange as well for creating these payment paths and liquidity for trustless issued currency. And of course, the transaction fees. So just some concluding thoughts. How this works is you can construct a multi-hop payment path in order to route a payment to its destination and use these trustless issued currencies that are, you know, just by default fungible and redeemable, et cetera. It's going to be important to pay attention to the liquidity providers who can kind of help create this burgeoning ecosystem, and we're developing a toolkit that will make it easier for development. There's a lot of things going on, and I think most importantly, having the developer experience for these sorts of new things occurring in the ecosystem, making it easy to use. That's what we are fixated on. So what we're doing in relation to this is building the Solaris Bridge. I kind of mentioned this. It's like a Flare smart contract, but also we're developing a SDK in Node.js that will make it easy to just plug in the kind of destination account, and it'll be able to construct the path, make sure that there's no counterfeiters involved, and make it just super easy for anyone who wants to develop on this sort of, using this sort of new currency. So that's very exciting. Also, something that came out of the work here is XRPL Composer. So this is how I created that original sort of graph in an earlier slide. So I was just going to give a quick demo on how this works. This is open source. It's already on our GitHub page, but it does need quite a bit of work. At least it's functional, though. That's what matters. So you can go ahead and build sort of the nodes in the graph here. You know, there's a couple already here. This is the same exact graph that I showed you. You've got Alice's account. You can see her trust lines. Everyone else here. You can create the nodes here. I won't walk you through that process right now, but you have certain options in order to construct sort of your graph, and then you can visualize it. Still quite a lot that we need to do here. There's a lot of things that we can improve and surface the right information, but at least this gives you a visual idea of what you've done, and then you can go ahead and validate that it's working as expected. So you know, this is just a payment form, and filling in the details, we're having Alice send one ORA to Bob, and we're using the RippleD sort of pathfinding tool. So it does recommend some paths, but I think for more complicated scenarios, it's better to construct the path on your own. So that's what we're going to do here, and I'm just going to copy that and paste that in. So this is kind of the path that we're constructing. It's going to go through the issuer A account and then through the liquidity provider account, rippling its way to Bob. And that is not the expected result because I had the wrong issuer. And now it's going through. It'll say, like payment completed, just a bunch of code. It used to be updated, but generally that will help you, figure out that this is your graph is working for this trustless issued currency. And again, the SDK will be coming out. So now I just need to switch back to the slides. Great. So that's the end of the presentation. I just wanted to give a shout out to Shine, my co-founder, who is, who has helped me and been tremendously important to the creation of what we're building here. And then, of course, Hugo and Sean from the Flare team, who Hugo wrote that blog post and then the technology behind the state connector. This would not be possible without these folks. So a big thank you to them, and thank you everyone for listening to me today.